K-means or something like K-means for segmentation, it has some strengths. It's very simple to do. By the way, it's guaranteed to converge. You can sort of show that. But it has some distinct challenges. First of all, it tends to be very memory intensive because you're keeping all of your points and you're shuffling them around in a membership way. Perhaps one of the biggest ones, well, actually there's two big ones. One is you need to tell it K. You need to tell it how many points there are, how many clusters there are a priori. And you can try to discover that, but K-means doesn't know anything about how to do that. It's sensitive to initialization and outliers. And in particular, what it's looking for are nice, essentially spherical clusters where they're spherical in feature space. That is, it doesn't want any point to be too far away. And the problem with that can be illustrated in a figure that looks like this. So here is a figure with two clusters in it, this one here and this one there. Now I've drawn them, or I should say they've been drawn in red and blue to help you think that they should be separate. But if you were to look at that pattern in just black and white, you probably would say, well, there's this bent cluster here, and then there's this bent cluster there. But of course, if you were to run K-means, you would get what's shown here. This would be one cluster, and that would be another cluster, because K-means is looking for these spherical clusters.